All right, how's it going? Hi, my name is Gio, and I'm here to talk to you about all of the unsexy things about shipping AI products to production. But before I get started, let me tell you a little bit about myself. So I got started when I came out of college in the finance industry in a subsidiary of Standard & Poor's. And there I focused on a search engine and database for globally sourced financial documents. And ended up also building sort of a real-time processing system for that database. So that was a lot of fun. It was a lot of data gymnastics. But finance didn't really make me feel all warm and fuzzy. So after a while, I made a break for it and ended up moving on to Etsy. If you folks aren't familiar with Etsy, Etsy is a marketplace for handmade goods. So think eBay, but more like something that someone would personally craft for you as a consumer. I was fortunate enough to spend 6.5 years there, and I focused mainly on search and data-driven product development. I led the search experience team, which worked on things like auto-suggest, result placement, facets, taxonomy, mobile user experience, and later on went on to lead the search ranking team, which was responsible for Etsy's core search ranking algorithm, both the effectiveness of that algorithm, but also its fairness. And then earlier this year, I moved on to Related Works, which is a company that I co-founded in February with a couple close friends. And we're working on building tools for libraries and museums to publish their digital content. So if you have any librarians in your life, I would love to talk to you. So I don't mean to suggest that I'm some brilliant dude. I don't have a doctorate. I wouldn't call myself a data scientist. I've just spent an extraordinary amount of time working with data, working with search, and I sort of think about myself as that awful glue code between your idea and what happens in production. And as it happens, what we're here to talk about today is that reality, right? And the stark contrast between people's impressions of what using AI is like and what you have to do and the things that you have to deal with. Most of the conversations that you probably have with folks, most of the papers that you read or the blog posts that you read, they're really about models. They're about, hey, there's this sexy new architecture for doing X, Y, Z, and somehow it's usually classifying cat pictures. But really, you're going to spend the majority of your time and the majority of your anguish on all this other stuff that we never talk about. And that's going to be the focus of my talk today. So we're going to get started by talking about infrastructure, or the literal plumbing that you need in order to put some sort of AI system in production. And then we're going to talk about the intersection of that system and human beings. Now, I'm not going to lie. This talk is probably going to sound like a giant bummer. And it sort of is. But what I'm really trying to do is not dissuade you from using machine learning algorithms back at your organization or business, but to help you understand what the work is. Because the sooner that you understand it, the sooner you can focus on the important pieces. So let's talk about plumbing. And I'm using the term infrastructure here very, very loosely. What I really mean is the inputs and outputs to your system. And we'll start with an example. Let's say that I want to do some sort of supervised learning. I'm a search guy, so let's talk about search. So this is a diagram of a very simple search ranking algorithm. The model, in this case, would be given a document that you want to score. And it may be given some context, like the query that's being issued by the user. So in this case, it's fanny pack. And the model decides how good this document is for that particular context and gives us a score. We take that score and we re-rank the results based on it. It turns out that the context is actually sort of optional. Query agnostic or context agnostic models can also be very useful for search. So the first thing that you're going to need for this ranking model is some training data. And you might say the training data might look something like this. So we'll take those query context or document context pairs and have a yes/no answer. Yes, this document is good for this context, or no, this document is definitely not relevant. So where might we get training data like this? The first place that you might try is Amazon Turk, right? Everyone is doing crowdsourcing these days. It's a very popular technique. But you'll find that subtle differences in the way that you design your task can actually have outsized effects on what your training data looks like. So there's an entire field devoted to the study of this sort of microsourcing. You may also find that you need an incredible amount of money to get the volume of training data that you would need to train the algorithm, right? Maybe tens of thousands or even millions of examples. And even if you summon forth, if you design a great task, and even if you are able to find a reasonable amount of money to accomplish the training data that you need, you might find yourself asking this question. And I've seen a lot of folks kind of turn a blind eye to the quality of their training data, right? Maybe they ask the crowdsourcers a couple questions. Maybe you're doing a little micro-election with each labeled instance, but you can still end up with some pretty not so great training data. And the easiest way of understanding if your training data is no good is getting labeled data. So sort of back to the beginning. And maybe this whole tirade is not for you. Maybe you say, hey, why would we ever pay anyone to do something we can get them to do for free, right? We've got this website. There's people using it all the time. We must be able to use their behavior to extract some training data. And that's a totally reasonable thing to try out. So here's an example of how we might do that on Etsy. So if a user comes to Etsy and searches for something like, say, fanny pack, the user clicks on a result, and we can take that as a positive example, and we can take everything else on the page as a negative example. This is a totally reasonable strategy, but it turns out that people's behavior doesn't really always line up with what your expectation is of relevance. For instance, if you were to train an algorithm on what people click on Etsy, you will almost inevitably learn how to classify scantily clad women. And I think at least once or twice a year, the search or data science teams would get paged because sexy stuff had sort of leaked into machine learned products. So this is a very easy mistake to make. A more subtle sort of bias can happen if you think about the position of clicks. So if we were to graph the number of clicks by its position, you're going to see a power law. You're almost certainly going to see a power law that looks something like this. And what you should get from this graph is that the majority of the clicks are in that top position or in that top row. If you feed this data to your ranker exactly the way that we discussed, your ranker is essentially going to learn how to mimic the existing search engine, which is not very useful, right? The whole point of training a new model is you want to do better than your existing model. So there are a lot of subtleties here, and that might lead you to say, hey, there's this new thing called transfer learning. Why don't we try that? That way we don't have to deal with training data at all. And the first challenge there is finding a model that actually accomplishes what you need to accomplish. So, this wolf versus husky classifier is not going to really do anything for my search ranking problem, right? And there might be a reasonable model out there, but again, we'll find ourselves asking, does it work for our data? A machine learning model, it is very difficult for a model to generalize to its training data, let alone to your training data. And again, the easiest way of gaining confidence that this transfer learned model will be useful for you is by having labeled data to test it against. Now, I've seen transfer learning be useful in a couple different scenarios. The first is by generating embeddings that you might use somewhere else. So for instance, you might take the last layer of an image classifier and use that as a vector representation for an image, and then use that to power an image similarity algorithm that's completely separate, or you might use it to train a completely separate model. I've seen that be very successful. And also if you have a very general sort of problem, like maybe you need to parse some English prose and extract some named entities, there's probably a reasonable model for doing that. But otherwise, you may need to do a bunch of work. So regardless of the path you choose, though, I'm completely glossed over the enormous amount of awful things that you will have to do to clean your data in order to be able to even train a model. And once you get past all of these hurdles, you might find yourself asking, like, is there an easier way? Is there a silver bullet here? Not that I know of. I think the only thing you can reasonably do is take all of these problems and really approach them with a healthy dose of skepticism, right? Like always be asking yourself, what is the value of my ground truth? how good is it, because that will have a more outsized effect on your outcome than almost anything else. So let's say that you successfully acquire some training data, you train a model, it's awesome, it's performing really well, you're really excited about it. Now you need to start incorporating that model into your production system. And I'm going to call the process of asking your model for answers serving inferences, or inference time. For search ranking, the inference may be the search engine asking the model for how good is this document. For a recommender system, that might be, hey, here's a new user, what are some recommendations that I can show that particular user? So let's say that your search engine's written in Scala and your brand new sexy ranking model is written in TensorFlow. How do you incorporate this? Your first option is RPC. So you can make a call out to TensorFlow over the wire. You can shell out to TensorFlow, get an answer for how good your document is, get answers for each of the documents in your set of candidates, and then re-rank the results. But now you have like a dozen new problems, right? Now you have to think about, well, what if this particular machine learning runtime doesn't have a service wrapper of some kind? Now I have to write a service for that. How do you monitor and deploy that service? What do you do about new models or new versions of existing models? If you're a Scala shop, do you really want to have a production system running in a runtime that you have very little experience supporting? I don't know. What does that burden look like when you have 3 or 4 or even more machine learning systems in production? What if it's slow? You know, for a single inference, maybe that's not too bad, but if your search engine has, you know, say 40 results on a page that you want to re-rank, those milliseconds can add up really, really quickly. So it's not uncommon for folks to just rewrite. So you'll take the existing model and rewrite it in your programming language of choice and maybe even run it in process, right? So in this example, the ranking model may be running within the search engine. And this is super common, especially as you have a number of machine learning systems in production. The explosion of complexity makes this very, very appealing. For simple models like logistic regression, this is a no-brainer, right? We just got to do a dot product like MBD. But for anything else, you're talking about a significant investment. And the moment that your training and inference time are different, you've introduced the ability for those two runtimes to have divergent code, especially if you're extracting features at inference time. Right? So in this example, we're gathering the words that we're going to use to create the representation for a document. At training time, we are essentially just splitting on white space and stripping non-alphanumeric characters. At inference time, we did the same thing, but we also stemmed. So now the vector representation of our documents don't line up. This is a very, very common problem. The third option is you can essentially just shove a cache in the middle, right? So in the search example, I might say, here's the top 100 queries on my website. I'm going to grab those. I'm going to re-rank them offline according to the results of the model, and I'll shove them in this cache. And then my production system can just ask the cache for the re-ranked results for the particular query that it's working on. And this can work really, really well, but now the coverage of your machine learning system is bounded by the capacity of your data store, which is sort of a huge bummer, right? The whole reason that we're doing this work is that we want to build learning systems that can impact the product in a meaningful way. If you can only re-rank the top 100 search results or top 100 queries, that's kind of not great. So again, there's not a perfect storm. There's not a perfect solution. There's trade-offs in every direction. But there is some hope in that it seems like there are more and more people thinking about sort of holistic, operable production pipelines for training and serving inferences. And I don't have any experience with these products, and I suspect that we're a couple years out from them being reasonable solutions. But I'm hopeful that 5 years from now, 10 years from now, we're not kind of cobbling together and making these trade-offs, or at least if we're making them, they're a lot less work. So once you have training data, once you're serving inferences and you've sort of tackled those challenges, at some point, your machine is going to have to meet some humans. And this is where I think it gets super, super interesting. Just because I think it's more fun, I'm going to talk about the top 3 reasons that in my experience I've seen AI-driven products fail. And these stories, some of them are scenarios, some of them are real stories. None of the people involved are dumb. They're all really brilliant. I love them, and I have made the same mistakes. The point is not, avoid these mistakes. The point is, take these experiences and understand the subtleties and the challenges and use them as a learning experience. So the first reason is that measuring stuff is not surprisingly hard. If you have some brand new model, I would recommend the easiest way of understanding how that model compares to something that's already in production is running an A/B experiment, right? A/B experiments are great, assuming that you have enough traffic to actually run an A/B experiment. And let's run through an example scenario. So let's say that we finally get this search ranking model into good shape. We put it in production, and the first week or so of our experiment is doing really well, right? The experiment model has a much higher conversion rate than the control model. Fantastic. But then a week or so later, the control just kind of comes back up and is suddenly performing just as well as the brand new model. What might be going on here? Well, you might be retraining on a regular basis. That's a pretty common thing to do. So we might take the last 6 months or the last few weeks of data and retrain the same model every single night or maybe once a week. And that's useful because you can pick up on trends, right? We might pick up on the fact that, hey, Donald Trump won an election, and now when people are searching for piñatas, Trump piñatas are a super hot item. If you didn't retrain, you might not pick up on these sorts of things. So if you're retraining nightly, now you've exposed the ability for these models to sort of change out from underneath you. So on day 1, you can see that the experiment and the control are very different. So in this case, the search query is shorts, and this is the top result. You can see the experiment has sort of latched on to denim being super hot, but the control is still peddling like cotton gym shorts. Now, when we retrain every night, we want to retrain our models with as much data as possible, right? Like, why would you withhold information from your model? We want them to be as great as possible, and we know giving them more data is a fantastic thing to do. But if you're not careful, that means the clicks that are occurring inside of your experiment may be being used as training data for your control model, and vice versa. And that means that both models are being exposed to information from the other side. So now they're learning from each other. And by day 20, what you'll find is that the two models will actually be very, very similar. So here we see that the control has picked up on denim and has ditched those cotton gym shorts. Now you might say to yourself, what's the problem? It seems like the control is actually pretty good if you just give it reasonable training data, right? Well, not really. The control is great when it's exposed to information that the other model is helping it learn, right? If you turn the experiment off, it's almost certain that the performance of the control will dip back down again. You can certainly assemble some sort of a combination of the two models if you like, but that's sort of a completely different experiment, right? The solution here is obvious, right? Well, let's just split up the training data, right? So in the control, we should only ever show the control model control data. The experiment should only ever see behavior that's coming from the experiment. Well, it's not that easy, right? What happens if we're running the experiment at 10%? That means that our experiment model has much less information to work with and is thus maybe underpowered by comparison to the control model. So these are just some fun examples of the sorts of things that can go wrong, and debugging and dealing with A/B experiments is probably another talk into itself, or several novels and books. And here's a couple things that I think about when I'm setting up an A/B experiment. The first is to think about your objective, right? What are we trying to increase or decrease in this experiment? And ideally, that objective lines up between your experiment and between the objective function of your machine learning model. So, hey, maybe we're trying to optimize clicks, let's measure clicks. That isn't always an easy thing to do, but if you can achieve it, it makes reasoning about what's happening much simpler. The second, which is what this story was about, is isolate. And that means isolate not only your training data, but also in your user experience, right? A user shouldn't be exposed to multiple versions of a model in one visit, let's say, or maybe you want to restrict it so that they don't see it for an even longer period of time. The more that you can isolate the effects of your change, the easier and clearer the signal will be. The third thing is only change one thing. And I see people make this mistake all the time. They get really excited about a model, and their eyes sort of glaze over, and they're like, oh, man, we got to change this, and it's going to be way better if we do this other thing. And you went from, I'm going to change the model that's in this existing experience to this brand new, really intelligent experience. And sometimes you have to make those leaps. But if you can avoid it, you should, right? You can always make the UI leap later, and you can always test it separately. If you muddle all of those changes and something goes wrong, it's going to be very hard for you to understand why it went wrong, right? You have too many confounding variables. The fourth is to check your instrumentation, right? Make sure that you're measuring the things that you care about. If we care about clicks, let's make sure that we're seeing events for clicks. But also, you'll probably want to run an AA experiment, so an experiment where both sides are the same, and there's actually no change, and what you expect to see is you expect to see a wash, and you expect the numbers on either side of that experiment to sort of mirror the numbers that you would see globally. So that's just a couple tips, but this is a huge, huge area where things can go wrong. And my slides went away. Okay. So the next failure mode is picking the wrong venue or approach for incorporating a model into the product. And my favorite example of this was the taste test, which is a product that a friend of mine built back in 2010. So the taste test was a game. You would show users a set of items, and they would select, like, I love this one, I don't like that one, etc. And then after you've made a certain number of selections, the model would learn to model your tastes, and it would recommend a bunch of items to you that you might be interested in. We spent an inhuman amount of time and energy taking this prototype and making it an operable production system that was using the same technologies as the rest of the website. And after that giant slog, we decided to put this product on the homepage. And the objective of the experiment was to increase registrations. At the time, I remember this is 2010, we thought that was a good idea. But what we didn't understand back then is that if you want users to do something when they're first landing on your homepage and they know nothing about your company, the easiest way to do that is put a giant button right at the top. I call it the big fucking button. It's like almost unbeatable. And if a passing visitor comes to your website and you ask them to play a multi-step game, it's kind of a giant ask, right? That's a huge investment that they're likely not to make, especially on mobile. So, not surprisingly, putting this product on the homepage, looking for an increase in registrations didn't work out. And after a while, the product withered away. And that's an easy thing to happen, right, when you have a failure like that. But I'm fairly certain that if we had picked a different venue for this product, we might have been more successful. Like, say, if we had put it in search, where users have demonstrated a great deal more intent, they're more invested, and they're looking for something, and they're really interested in getting feedback, that venue may have been much more successful. And we had a lot of evidence that users were highly engaged with it. The forums, the press, people were really excited about it. But we chose the wrong spot, we didn't deliver, and it ended up dying. And the lesson here isn't always pick the right spot. The lesson is don't let it die with your first failure. You got to keep going, and oftentimes you're going to find you're going to need a different approach or a different location for that same product. And in a lot of cases, it means you need to take that model and maybe power a completely different experience. So the third, and I think most prominent reason that I've seen AI products fail is because models come first. And I see this happen all the time. I literally did this 2 days ago. Hey, I read this paper, this really cool model that does X, Y, Z. And if that's the start of the conversation, you're basically screwed, and you should just give up. And here's a great example of it. So a couple of years ago, we saw the same story play out, and I can't remember what the model was at the time, but if the story were happening today, it would be Word2Vec. And the story would be something like, hey, we have this really amazing model. We can get vector representations for words, and then we can understand which words are close to one another or have similar relationships. So in this case, navy, it's kind of like blue. So what can you do with a model like that? Well, you could do something like query expansion. So let's say that the user searches for navy tote. We might say navy or blue tote. And that will help because if we don't have enough navy totes, there's going to be more stuff for them to look at. And navy and blue are pretty close, so this should be a fairly reasonable thing to do. Now, query expansion is not a bad idea. It's actually a great idea. Here we see I'm searching on Google for Indian Sea. Google understands that the Indian Sea isn't a thing, but that seas and oceans are pretty comparable, and it shows me a result for Indian Ocean. So query expansion can be very useful. It's very common. You see it all over the place. It wasn't a bad idea. The problem is, in the context of Etsy, it was not the greatest idea. And to understand why, we sort of need to go back to information retrieval 101 a little bit and talk about precision and recall. Now, I could talk about precision and recall by showing you some math or the table on Wikipedia and true positives and false positives and that kind of jazz, but I like to think about it this way. If in search you have precision problems, you're probably seeing a lot of garbage results, right? Like things are just not relevant. If you have recall problems, you don't have enough results or enough relevant results, right? So you might search for something, only get 5 when you should be getting 5,000. Now, it turns out that Etsy has a big precision problem, or is dominated by precision problems. So in this case, for the query wedding dress, we're seeing a bunch of wedding dress hangers. And it's easy to understand how that mistake can be made, but from the user's perspective, that's a fairly bad experience, right? They clearly don't want wedding dress hangers. What they want is wedding dresses. And the query expansion exacerbated this problem because it took words and expanded them to other words that were related but fundamentally different. So if a user was searching for a 1920s dress and you showed them 1930s dress, well, those are completely different styles, right? Now we look like fools, right? We don't really understand the user's intent, and so not surprisingly, the experiment didn't do well. Now, the source of the problem is obviously we came with models first and then kind of applied them to users after the fact, right? And the solution is, sort of obvious. If we had started with users, we would have understood that precision problem was such a big deal, and we would have understood that increasing recall in a very aggressive way could exacerbate that precision problem. But we also would have understood that there's a lot of other recall opportunities. So in this case, I searched for jewelry and I got no results because I misspelled jewelry. And it turns out that there are many instances where users were getting no results because they misspelled things or because they filtered too much. And these are great opportunities to increase recall that aren't dangerous at all. But again, we're starting from that user story and then building the models that we may need, if we need any. And that's the obvious solution, but I'm kind of a little embarrassed to even talk about it, right? It should be obvious we should always be thinking about users before we build models, and yet I see this story repeating itself over and over again. And I think part of the problem is that the conversation is always about models. We don't talk about all these other things. And we certainly don't talk about, here's this really fantastic model, we tried to use it, and it was a spectacular failure. But that happens all the time. And I hope that by confessing a little bit about our failures and about the trouble that you might have putting these systems in production, I can stimulate some of that conversation, at least here in Hungary. The other thing I would recommend is get the people that work on AI as close as possible to the people that work on product. At Etsy, we had a lot of success embedding data scientists in product teams, and we even reorganized to have data scientists in the same organization as product engineers. So I sat next to data scientists for the last 2 or 3 years. And I think that's been really great on both of our parts. So I hope this has been useful, if not entertaining. And here's a very short list of the things I think that you should care about and the order that I think that you should care about them. And not surprisingly, models is all the way at the bottom. So start with humans and then figure everything else out after the fact. That's it. One last shameless plug. The name of my company is Related Works. And if you know any librarians or archivists, I would love to talk to you. And that's my email. Thank you.
Thank you so much, Gio. So we have some questions for you. So first question, what cloud, let's just check. I've got to work out this in the right English. So what cloud platform do you suggest to use for ML in production?
I don't think I have a credible recommendation. We were training and deploying our models in-house at Etsy. We were definitely very excited about GCP, but I don't have enough experience with it to give you a real recommendation. I would feel like I'm lying to you by recommending that.
Right, okay. Yeah. So next question. Should data scientists deploy their own trained models to production or hand it over to other teams?
I think you want something a little bit in the middle. So we actually had sort of a machine learning and search infrastructure team that sat next to us. And they were, in effect, also part of that conversation, right? Like, as we're working on a product, we're identifying, hey, we might use this type of model. This is a gap in our infrastructure. We don't know how to serve this. We don't know how to train this in production. And they would shepherd that process. And a lot of times, I would be doing that work, or some of the other engineers on the ranking team would be doing it. Sometimes we have a very DevOps-y data scientist. Sometimes they would do it. So I think it depends. I don't think you want either of those extremes. I think data scientists should be aware of the work that needs to be done in order to put things in production, at the very least aware. And I think any time that you have deployment happening as a completely separate thing that's handed off to another human, I think that is kind of a recipe for a disaster.
Okay, so how do you envision the future of deep data in Etsy?
I think deep data is going to be the word deep data is really weird to me because I usually think about deep learning models, but I'll assume that that's what folks are asking about. I think it's going to be super important because Etsy is such a visual place. So I think there will be a lot more use of visually extracted embeddings to, power. I think about Etsy on sort of the supply and the demand side, right? So the supply side is sellers giving us content that they want to sell, and the demand side is consumers coming and trying to purchase things. And I think those sorts of features are really useful on both sides. On the supply side, I see these being very useful to augment the data that sellers are giving us, or to suggest more structured data. So you may, upload an image of a ring, and you tagged it jewelry but forgot to tag it ring. We can figure that kind of stuff out. It's also super helpful in evolving your structured data, right? So you may not have the concept of ring sizes or some other structured piece. We can use models to fill in those gaps, but let sellers know, like, hey, it looks like you didn't fill in this piece of information. We think that this is what you meant. Yeah. Check it out. And then I think on the consumer side, it'll be really useful to understand people's tastes and figure out what they're really going for. I think the taste test was kind of like a very, very, what's the word that I'm looking for? Prehistoric step in that direction. I think a lot of the visual stuff will be very useful there. But I think it will also become more embedded in the product itself, right? As you're searching, as you're clicking around, we're going to be able to get that visual vibe of what you're going for.
Get a better understanding. Okay, so in the shorts test, what made some users in the control be exposed to the experiment and vice versa?
Okay, this is, I had a running bet with some of my colleagues that I would or would not be able to explain this. So. The problem isn't that users are exposed to the control or the experiment. The problem is that we were taking all of the data. So 100 users come to Etsy, and they all click on stuff. And some of them were clicking on stuff in the experiment, and some of them were clicking on stuff in the control. We took all of those examples and retrained our models every night. So that meant that people were clicking on things that they were exposed to in the experiment, but that labeled instance was being sent to the control as training data.
Okay. All right. So let's do two last questions, okay? So how do data scientists document and communicate their ideas and results of their projects at Etsy to product and engineering people? I'm thinking, you see, for me, that's like English.
Yeah.
We write ENG. So, yeah, so for product and engineering people.
I think the same way most other folks do. I mean, a lot of documentation, a lot of conversations. I think very few times I've seen cases where, you know, data scientists are working in isolation, right? Like in my ideal universe, we start with that user problem and we're like, hey, we have this homepage, we're redesigning it, what should we put on it? We'll have, you know, an analyst on board, we'll have a data scientist, and they'll be part of that conversation of how do we improve this experience. And that's probably going to start with, well, you know, what are people doing on the homepage? Why are they coming there? What are the metrics that we're interested in? And kind of, you know, go out from that. That being said, you know, sometimes, obviously, there are ideas that start in the other direction.
Yeah.
And a lot of that is just get a Google Doc together, send it around, put your idea into words. And I see this a lot with analysis and a lot, you know, if people send you like this giant IPython notebook or like this Excel sheet, it's just not going to work, right? Like no one can open these up and really understand what you're getting at. And so what I suggest to folks is, you know, write a one-pager that you could send to the CEO that if he could understand what you want to do, then you're going to get somewhere.
Yeah. It's that whole kind of keep it simple message that we've been getting literally for the last 2 days. Yeah. Right, so this deep data business keeps coming back. So, in your opinion, what is deep data?
I mean, this conference is the first time I heard that phrase. My interpretation of that...
it's like been the buzzword of the conference. Yeah. Deep data here, deep data there, deep data everywhere.
Yeah. I mean, my interpretation of that would be I assume that we're talking about leveraging deep learning models is my expectation. There could also be some, you know, I guess another angle on it, which is maybe a completely different thing, is the idea of, you know, going farther out with what you're understanding. So I was actually having this conversation with Ronnie, who spoke yesterday. Yeah. A lot of times, what you do is really going to be governed by what you measure. Right? And so I've seen a lot of cases where we're really good at measuring short-term effects, right? Like we're really good at running an A/B test and understanding if the click-through rate or the conversion rate went up or something like that. But, you know, what about longer-term effects, right? There's the lifetime value of the customer, but then there's this whole other operation, right? There's like support requests and non-deliveries and like that other side of the business, right? And so one interpretation of this phrase that I've never heard before might be, you know, going beyond that like very, very shallow understanding of what's happening and tying together that whole life cycle of your business.
Yeah, it's the kind of lifting the carpet of the bits that people don't like to talk about. Yeah. Okay, great. So I'm going to do one last question. So have you considered working with Pinterest for taste models?
I think I know that we have folks that have talked to Pinterest. I think that's the extent of how I can answer that question. But yeah, we would love to. Yeah.
Okay, great. Yeah. You have been fantastic, Gio. We have a little gift for you. One last one, almost. This is a picture of you, and we'd like to gift it to you for being so wonderful and sharing your information experience with us today. So thank you so much. Please give them a clap.